Hello, good morning everyone. Today we are going to start Operating System Unit 2 Session 10. In the previous session we have started with the concept CPU scheduling algorithms, and from that we have studied the first CPU scheduling algorithm, first come first serve, and we have also seen some problems on first come first serve CPU scheduling algorithm. In today's session we will see some more problems on first come first serve CPU scheduling algorithm. So in this problem they are given the processes, arrival time and the burst time. Now if you observe this arrival time, you can see at unit 3 there are two processes has arrived here. So how to do this we are going to study now in this problem. So always start with the unit 0. You can see here there is none of the process which has arrived at the unit 0. So at unit 0 the CPU is going to remain idle, so that you are going to represent in this way. So this indicates the CPU is idle, and check out at unit 1 is there any process arrived. At unit 1 also none of the process has arrived. So from 0 to 1 it is going to remain idle, and from unit 1 to 2 even the CPU is going to remain idle, because at unit 1 none of the processes arrived. So from 0 to 2 the CPU is going to remain idle. Now from unit 2 onwards the process have started arriving in the ready queue. So at unit 2 which processes arrived here? Process 5. So allocate the CPU for process 5. Now process 5, for how much unit it is going to run? Unit 1. So 2 plus 1 how much? 3. So unit 1 it is going to run 2 to 3. Now at unit 3 two processes has arrived in the queue. That is, see here. At unit 3 two processes arrived on the queue. That is process P2 and process P6. So when process P5 was running, two processes arrived here, process P2 and process P6. Now from these two processes has arrived on the same time. Now in such cases you need to consider the lower process ID of the process. So you have to select such process which has lower process ID, and that is process P2. So process P2 is the lower process ID. You are going to select that. So when the processes arrives on the same time, consider its lower process ID and allocate that process to the CPU. So P2 is going to run for how much time? 4 units. So 3 plus 4, it is 7. So the process P2 is going to run from unit 3 to unit 7. So it is going to start from beginning 3 and ending 7. Now next process. Now when the process P2 is running, check out if any of the processes has arrived in the ready queue. There is already process P6 available in the ready queue. Okay. Now check out, yes, at unit 7 another process has come, process P3. So the first process which has come is P6. So allocate the process P6 to the CPU. Now P6, how much unit it is going to run? Only 1 unit. So 1 unit it will run from 7 to 8. Then when the process P6 is running, check out any of the other processes arrived. Yes, unit 8 process P1 has arrived. At unit 8 process P1 has arrived. But process P3 has come first, so allocate the process P3 to the CPU, and P3 is going to run for how many units? 6 units. So 8 plus 6, how much? 14. So process P3 is going to run till 14. So process P3 is going to start at unit 8 and end at unit 14. Now when process P3 is running, find out if any of the other processes has arrived in the ready queue. See, at unit 8 already it has finished. See, at unit 10 another process has come, that is process P4. So we already allocated process P3. Now P1 has come first before P4. So allocate the CPU for process P1. How much unit it is going to run? 2 units. So 14 plus 2, 16. Now last process which is remaining is process P4. For how much unit it is going to run? Process P4. See here, 3 units. So 16 plus 3, 19. So process P4 is going to start from unit 16 and end at unit 19. Now this is the chart and the CPU allocation of the processes. Now form the table. So they already given the process numbers, arrival time they are given and burst time they are given. Now we need to find out the completion time of the processes. So what is the completion time of process 1? Completion time of process 1 is 16. Completion time of process P2 is 7. Completion time of process P3 is 14. Completion time of process P5 is 3. P6, 8. And so on. So that you need to write here in the completion time column 16, 17, 14, 19, 3 and 8. Now you need to find out the turnaround time, completion time minus arrival time. So completion time minus arrival time, consider these columns. See 16 minus 8. So this is the answer, turnaround time. Waiting time, turnaround time minus burst time. So turnaround time minus burst time, consider this column values. See 8 minus 2, 6. Then find out the average waiting time of these values and average turnaround time of these values. And you will get the value here, average waiting time 2.83 and average turnaround time 5.66. Another problem we'll see, calculate average waiting time or turnaround time. So they are given this problem, process IDs, arrival time and burst time. Now check out from the unit 0 which process has arrived. Yes, at unit 0 process P1 has arrived. Until how much time it is going to run? Till unit 5, from 0 to 5 it is going to run. Now when process P1 is running till unit 5, check out if any of the processes are in the ready queue. Yes, at unit 2, process P2 has come. It is already in the ready queue. So allocate the CPU for process P2. So how much time it is going to run? 3 units. 5 plus 3, 8. Now when process P2 is running, check out if any of the other processes are in the ready queue. Yes, at unit 6 process P3 has come and at unit 7 process P4 has come. So when the P2 is running in the ready queue, process P3 has come and process P4 has come. Okay, now the first process which has come is P3, allocate the CPU for P3. P3 is going to run for 2 units, so 8 plus 2, 10. Now next process, that is P4. P4 is going to run for 3 units. So 10 plus 3, how much? 13. So this is the chart of CPU allocation of the processes. Now form the table. So process number already given, arrival time already given, burst time already given, completion time we need to find out. So the completion time of process P1 is 5, completion time of process P2 is 8, 10 and 13. That you are going to show in this column, 5, 8, 10 and 13. Then find out the turnaround time, completion time minus arrival time. Completion time minus arrival time, you will get turnaround time. Waiting time, you find out turnaround time minus burst time, you will get waiting time. And then calculate the average turnaround time of these values and calculate the average waiting time of these values, and total how many processes are there? 4. Divided by 4, and you will get these values, average waiting time and average turnaround time. Now, as I told you, there is a convoy effect in the first come first serve algorithm. So it is nothing but in a first come first serve algorithm, if the first process is having large burst time, then it will have a drastic effect on average waiting time of all the processes. You can see 2 examples we have taken here. They are given the number of processes, arrival time and the burst time. Okay, so the burst time of process P1 is, first process is more here, and the remaining other processes burst time is less. So the process first is going to take too much long time for execution. So because of first process, even other processes has to keep on waiting even if their burst time is less. So in such case, the average waiting time you will get of all processes is more here. Now, if you take the same example, but the first process burst time we are taken here at the end here. So in such cases, there is a less burst time, means the average waiting time you get is less, it is 1 unit. So when you compare these two, in the first case you will get average waiting time 13, in the second case you will get average waiting time 1. So this we call it as convoy effect, because if the first process has more burst time, all other remaining waiting time of processes increases. So here we have completed first come first serve scheduling algorithm. In the next session we will start with a new algorithm. Thank you.